let's start. Motion in two dimension. Okay, so that is motion in two dimension or motion in a plane. Motion in two dimension or motion in a plane. So first we need to understand the concept about it. What is the concept of motion in two dimension? So motion in two dimension means the path the body is moving, or the trajectory in which the body is moving, that trajectory lies in a plane. That means there is a plane which can pass through that trajectory. So any two-dimensional figure, for example, a rectangle, a square, a circle, a parabola, a hyperbola, all such kind of path is two-dimensional figure. Okay. So what is meant by 2D motion? 2D motion, what is the concept? 2D motion concept is that, let us say the body is moving in a path. This path is a function. So y will be a function of x. X and y are function. And this function is definitely not a linear function. If it is a linear function, that means it is a straight line path. So the path in which the body is moving, it is not a straight line path. It can be a straight line also, but two-dimensional motion is classified for non-linear path. Okay, the path is a non-linear path. So y equal to f of x is a non-linear function. Non-linear function. Okay. Now suppose, for example, at any instant of time the particle is here, x comma y. X comma y is the position, and this is at an instant time equal to t. Okay, so as the particle is moving, this particle is moving, right? So after some time this particle can come here. This particle will come here. So this particle will come here after some time. So that means time, if you consider as t plus delta t, next time is t plus delta t. So initial time is, let us say, at an instant time equal to t, and some time afterward, that means at an instant of t plus delta t, the particle will come here. So that means its x coordinate is also changing and its y coordinate is also changing, or something must change. So that's why the change will happen, right? The path will be there. So it may be x plus delta x and y plus delta y. So x and y function is a non-linear function, and with respect to time both the coordinates are changing. Both the coordinates are changing, right? So at any instant, if you see the body is moving, so the velocity, what about the velocity? So velocity will be along the tangent. Velocity is along the tangent. So this is the velocity here. Let us say here velocity is v1, and of course it is a vector. Here the velocity v2 vector will be like this. So velocity is represented by a vector. That means in this chapter you must know the concept of vectors. Without vectors you cannot solve questions on two dimension. Means complicated question. Easy question you can solve, but if you want to learn better techniques, so vector calculations are important. So in this chapter we'll also discuss vectors and the laws of vectors, all those things. Okay, so velocity will be changing, and velocity is along the tangent at that point. Okay, so with respect to time both the coordinate changes, and the relationship of x and y is a non-linear function. That is what is two-dimensional motion. Sometimes, suppose for example, if a body is moving in a straight line, then y equal to f of x, let us take example 2x plus 3. This equation relation is there, but this is a straight line, so we can say that it is one dimensional motion. This you can say 1D motion, one dimensional motion. So the relationship between x and y, that is important. That relationship between x and y must be non-linear. Okay, That is the important condition for two-dimensional motion. And with x, with time, both coordinate changes. With the time, x will also change, y will also change, and the relationship will be nonlinear. So that's the main idea. That is the main idea. Now here you have to understand that the position x and y both are changing, both are vectors. So what are the things? Velocity is vector, acceleration vector, positions are vectors, but only time is a scalar quantity. Time is scalar. Time is scalar. Time is scalar. X, y, acceleration, velocity, all these are vectors. All these are vectors. Okay. So at a given instant of time, both x and y are changing, right? So we can calculate the velocities, we can calculate the accelerations, we can calculate everything. So first idea is without going into vectors, how can we study that? Without going into vectors. So let us consider without going in detail into vectors. So if x is changing, y also changing. So you can study the motion along x-axis and motion along y-axis, right? So you can study the motion of this particle along x-axis, along y-axis separately, independently you can study, but you have to study simultaneously. This is a very important concept. So motion along x-axis, motion along x-axis and y-axis can be studied independently but simultaneously. Okay, so what does that mean? So if you want to study the motion along x-axis, you can study. If you want to study motion along y-axis, you can study. What does that mean? What does that means? Let's understand what is meant by that. So if you are studying the motion along x-axis, motion along x-axis, and if you want to study motion along y-axis, okay. So previously in one dimension we were only studying either along x-axis or along y-axis. So for horizontal motion we are taking x-axis, y-axis, vertical motion. But here both the things are happening together. So you let us take for example a particle is going along path. Suppose there is a particle which is going along some two-dimensional path. So two-dimensional path is there. So at any point this is position x comma y. As I already told that after some time its position may change, x plus delta x, y plus delta y. So it is happening in a time interval of delta t. So in a time interval delta t, the x and y position changes. So if I only study x, note that if I am going to only study x, that means here let us say it is x, and of course it may be here. So after that it may become x plus delta x. Remember the body has gone some other position, it is not lying in the same straight line, but you can study this displacement along x-axis, which is delta x. Okay, delta x is displacement along y-axis. Similarly, if the body is moving this way like this, but I want to write its y coordinate now, so I can write y coordinate as y. Here y coordinate will be y plus delta y. Okay, so here this was x coordinate is x, and here x coordinate after some time it's coming x plus delta x. X coordinate means this position, right? So x is changing from x to x plus delta x. Here y changing from y to y plus delta y. So here you are only going to study the y displacement along y-axis delta y. Here you are only studying displacement along, although the path is different. Note that the path in which the body is moving is a different path. It is neither along x-axis nor along y-axis. That path is different path. But you can study separately x-axis motion and separately y-axis motion Remember, in the same time interval, you have to study this motion in the same time interval delta t. Here also the same time interval delta t. Delta t is the common factor. Delta t is the common thing which is connecting these studies. Okay. Then next thing that you have to study, now if you are studying separately everything, so let us now define everything separately. So displacement along x-axis in general can mean x2 minus x1, right? And displacement along y-axis means y2 minus y1, right? Displacement along x-axis and y-axis. Similarly, what is velocity along x-axis? Instantaneous velocity is dx by dt, right? Velocity along x-axis. And average velocity along x-axis is, average velocity will be delta x by delta t. Similarly, what will be instantaneous velocity along y-axis? dy by dt, dy by dt. What will be average velocity along y-axis? Delta y by delta t. All the same definitions now we are writing, but we are writing along x-axis and y-axis. Similarly, what will be acceleration along x-axis? Instantaneous acceleration means differentiation of velocity along x-axis. Similarly, average acceleration along x-axis, average acceleration is delta velocity along x-axis by delta t. Similarly, here also we can write acceleration along y-axis is differentiation of velocity along y-axis with respect to time, and acceleration along y-axis average if I want to calculate, so change of velocity along y-axis by delta t. These are the basic definitions which we have already studied in motion in a straight line. Very fundamental basic definition, never we should forget. Without this, no whole concept will go away. So this is the very basic fundamentals. Okay. Of course, jerk is also there, but jerk no need to study. That is not there in syllabus. Okay. So this is what it is. And all the graphical analysis can also be done. For example, if I want to study the graph of body, so I can study the graph of x versus time, x versus t, and at the same time I can study the graph of y versus t. So y may be changing with time, x may be changing with time. These are different variations, because these motions independently we have to study, but simultaneously we have to study. That is what it is. So in the same time x and y changes, you have to study. Similarly, you can study velocity along x-axis, velocity along y-axis, acceleration along x-axis, acceleration along y-axis. Everything will be considered. Similarly, here you remember another equation of acceleration. Acceleration along x-axis is v dv by dx. This velocity is along the x-axis. Similarly, acceleration along y-axis can also be written as v dv by dy, but this is along the y-axis. Okay, like that all the definition will be true. Then we can study everything. Okay, then so this is the very fundamental. Then we can go into motion in 2 dimensions. Now, before going into that, let us see some example. Lot of examples are there. Let us see some examples. Okay. Yeah. Write it. Okay. Done. Okay, then let us go next. Let's take example. Suppose if a body is moving and x and y coordinate are changing. Okay, let us say x coordinate is changing with time like this. X is equal to 2t plus 3 and y coordinate is changing as t square. Find the relation between x and y. Is it a 2D motion? Is it a 2D motion? Plot its graph. Try this. Yes, how do we do that? So try to eliminate time here. Time here, try to eliminate. So if you eliminate time, so from the first equation, you calculate time. So time become x minus 3 by 2. Then substitute in the second equation y. Square of this, so x minus 3 by 2 whole square. Right, you can clearly see that this is the equation of that. This is the relationship between x and y. How do we plot this graph? Yes. Do you have idea of plotting the graph? Without mass, you cannot do that. Okay. So plotting of graph is a very important idea. Without that, you cannot solve problems in physics. So first of all, you can see here y is a linear function this side, that side x minus 3 by 2 whole power is 2, that is like a quadratic function, right, second power. So these type of equations like uh, y square equal to 4ax, y square is equal to 4ax, 4ax, x square is equal to 4ay. These type of equations are parabola. First of all, we have to note that these equations are parabola. Parabola means x is linear, y is x power is 1, y power is 2, or y power is 1, x power is 2. So this type of functions are parabola, and it's a standard graph. I think you must know that. So y square equal to 4ax, this equation is like this. If I plot x and y graph, so y square is equal to 4ax graph is like this type of parabola, where origin is the vertex 0, 0, x axis is the axis of the parabola, and here a point will be coming here, a comma 0. Okay, a means capital A, but you can write as capital A, capital A comma 0. So this capital A comma 0 is also known as focus. Focus is the focus of parabola. Okay, and if you draw a perpendicular at the focus here, this distance total length is called latus rectum. So this, if you put x is equal to a here, so 4a square under root, this coordinate become a comma 2a, and this coordinate become a comma minus 2a. Okay, so this total length becomes 4a, that we should note. The total length becomes 4a. So 4a is the length of latus rectum. Length of latus rectum. And the focus a comma 0 is the focus. A comma 0, this is the focus. This much basic we should have. Oh, okay. What about this y square is equal to x square equal to 4ay? This type of function is like this. It is x, y, and this type of function can be plotted. X square equal to 4ay means this type of graph, like this. Here origin is 0 comma 0. This y axis is the axis of the parabola. Okay, note that here y axis is the axis. In this case, axis is the axis of the parabola. So more detail I have covered this in basic maths. Okay, anyway, have you studied this conic section? But in physics you must know from the beginning itself, otherwise you cannot solve, you will face difficulties. So parabola, hyperbola, ellipse, all these equations we should know. Here I am just covering with this example, this part. So this equation y square equal to 4ax represent a parabola. Yes, first draw. Okay, again I will draw. So suppose if I take this as x-axis and this as y-axis, this graph, which is going like this, it's a non-linear function. This graph is y square is equal to 4ax. Okay, and origin 0 comma 0, and this axis is the x-axis, and this point which is a comma 0, and when you draw a perpendicular, these coordinates also you can calculate, a comma minus 2a, this will be a comma plus 2a. This length is called latus rectum. This total length becomes 4a. Okay, so in this equation of parabola, first of all you should know that its vertex is nothing but the origin 0 comma 0. 0 comma 0 is the vertex of this. Second point, you have to note that x-axis is the axis of parabola. Axis of parabola. Axis of parabola is the x-axis. And then third point you should know, focus. Focus is a comma 0. Fourth point you have to note, latus rectum. Latus rectum. Latus rectum length. Latus rectum length is 4a. Okay. This much information we should know. First of all, this is a very basic equation. This equation we should know. Now, suppose if the first of all, are you clear about this equation? Y square equal to 4x represent parabola. This is called parabola. This is a standard equation. Okay, standard equation. and these are the details of this. So its vertex is origin, axis is the parabola, axis is x-axis, focus is a comma 0, lattice rectum is 4a. Okay. Now here suppose suppose I write a equation like this. I do not have the exact equation, but I have similar equation. Suppose I have equation of y minus 2 whole square is 16 x minus 3, like that. Okay, suppose I have equation like this. Now you must clearly know that this parabola and this parabola is exactly similar, not same but similar. Now the question is, how can I plot this graph? This graph is a standard graph. How can I plot that graph? How? Yeah. What is y square value? How will you plot this graph? That is my question. Hmm? Let us plot this graph. This graph, have you noted this graph? Have you noted this graph? Write it, this graph. Now we will learn a method called method of shifting the graph. How can you shift a graph? That method you have to learn. Okay. And this method is going to be useful in everywhere whenever you solve problems. Okay. Method of shifting. So what is that method of shifting? Once you have drawn this graph, how can we draw that graph? If you know this standard graph, you can draw that graph very easily, very quickly you can draw it. Okay. How? I will now draw this graph. I will draw the first coordinate system. This is coordinate system y-axis, this is x-axis. This is the origin 0 comma 0. Now first of all you should know that if you see standard equation, when you put this y equal to 0 and x is equal to 0, this 0 0 becomes origin, that is the vertex. Now here you put this term 0 and you put this term 0, left side 0, right side 0, you put it. So when you put 0, this, that means y has to be equal to 2, right? Y has to be 2, and this 0 means x must be 3. So you have to take a point which is 3 comma 3 comma 2, because x is 3 and y is 2. Now what you need to do is you have to make a graph like this, shape exactly same like this, it is going to bend like this. Okay. So this graph and this graph, the only difference is that this graph is not at origin, vertex is not origin. That means this graph is like, it got shifted. So you may say that this graph was here and we have shifted that graph there. How much shifting you have done? You have shifted x and y, both coordinate you have shifted it. Understanding? So you are shifting the graph by how much? You have shifted the x coordinate 3 and y coordinate 2. Okay. So this is how you can draw the graph. That's all you have to know, and everything remains same. And here the x axis of this graph. What is the axis of the graph? Axis of the graph is parallel to x axis. That's all. What is the lattice rectum? Lattice rectum also length you can calculate. You draw here. So remember, this 16 is nothing but 4a. 4a is 16, means this length is 16. This total length is 16. This total length is 16. And if you have to calculate what is a, that means this distance from here. So this 16 is 4a, right? 16 is 4a. 16 is equal to 4a. So a becomes equal to what? 4. A is nothing but from here to here, this distance is a. This distance is a, correct? From vertex to focus, that distance is a. So if this distance is a and this coordinate is 3, so this coordinate will become 3 plus a. 3 plus a is 4, so this will become 3 plus a. Y coordinate is same, 2, it doesn't change. So the focus is now here. What is the focus here? Focus is 3 plus a comma 2. But a we already calculated, a is 4, so 3 plus 4, 7, 7 comma 2. This is the focus. Clear? So from the graph you can see everything. Although the graph is not in standard form, but you can convert it into standard form very easily. Are you clear about this? Yes? So this is what this much you have to know, and this is standard form of parabola. Other parabola is exactly same, but it is coming in the upward direction. X-axis, y-axis is the axis of that parabola. Everything is same. I'm not plotting it, but you can plot it. Okay, it's very easy. So shifting, now the shifting of the graph is what you have to learn. Now I am going to tell you shifting. A very important technique is there, shifting of the graph. So note that if this graph has to be shifted in the positive x-axis direction and positive y-axis direction, then y you have to write y minus something and x you have to write x minus something. When you subtract, then it will move forward. This graph will move forward when you subtract, but when you add, it will move backward. This is what important thing to note. Okay, so now let us understand shifting of graph. Okay, you have not noted. Okay, write this. Okay, got it? Done, right? Okay, so Let's move. Now I will give some example of shifting the uh, which I will telling here. Okay. So shifting of the graph. Shifting of graphs. Suppose y equal to, let us take example 2x plus 3. This graph is there, you know it's a straight line, and to plot a straight line is quite easy because this is y, this is x, and suppose I put x is equal to 0, so y will become 3. X is equal to 0, y is equal to 3. This is one point, x is 0, y is equal to 3. And if I put y 0, y 0, if I put x become minus 3 by 2. Somewhere this side it will become, right? You'll get y minus 3 by 2, x is 0. That means you are getting these 2 points, and then you can plot this graph. Straight line you can join, because a straight line graph means 2 points is sufficient. So you know these 2 points. Okay. Now I want to make a graph whose equation is y equal to, not this. I want to make equation of graph whose equation is y minus 2 is equal to 2x minus 3 plus 3. Exactly same, but only thing is that you see what is happening. Instead of y I am writing y minus 2. Instead of x I am writing x minus 3. Correct. That's what it is. So I am doing some shifting here. This is called shifting. We are going to shift this graph. So this graph which was there, which was y, now I am writing as y minus 2. This was x, this I am writing as x minus. So we have to shift this graph. So what is meant by shifting is, you clearly see here, it is an example. It is an example to understand what is called shifting of a graph. Okay. So if instead of y, if it is y minus 2, it can be y plus 2 also. That example also I will take. But there is some changes in x and y in this graph and this graph. Okay. So if you know this graph, let us say you know this graph, how can you plot this graph? That graph can be plotted by shifting from the original graph. How can you shift? Now you should know that y minus 2 means 2 you have to shift along y axis. So this same graph I have to shift 2 along y axis, and I have to shift 3 along x axis. So let us try to shift it. This is the graph, right? I will copy this and I will paste it. Okay, this graph I have pasted it. Now see, this is the original graph. Here I am going to shift 3 along x axis and 2 along y axis, like this. Might be somewhere here it will go. We have shifted it. Okay, like this, somewhere here it will go. I just done randomly. So that means um, now you can see where this graph is, actually where this graph will be cutting. You can think about it, where this graph will cut, x-axis and y-axis, where this graph will cut. Can you think about it? If suppose I say this graph is cutting x-axis means y is 0. If I put y is equal to 0, what will happen? What will happen? This will become, check, put put y equal to 0. Put y equal to 0. What will happen? This will become here minus 2 minus 2 minus 3 minus 5 by 2 minus 5 by 2 plus 3. That will be x, correct? So x will come as, previously how much what it was? It was 3 by 2, correct? 1 minute, let me check this properly. So I put y equal to 0, so it has become minus 2 minus, I will write it like this, minus 2 minus 3 divided by 2 and plus 3. So let's try to understand this one. This I can write as minus 3 by 2 also, minus 3 by 2, and this has become how much? Of course, minus 5 by 2 it is. This is, but I want to write separately. This minus 3 by 2 I want to write separately, and then this is minus 1 plus 3. So it is minus 3 by 2 plus 2 plus 2, correct? That means from here, you can add this now. Means basically you are doing addition only. This is going to be minus 1.5. This will be half. So x is becoming half. So it is cutting here half comma 0. Similarly, where it will cut y you find out where it is going to cut y. Same way, put here in this equation x is equal to 0. If I put x is equal to 0, what do you get y? Y is equal to 2 plus 2 plus x is 0, so 2 into minus 3, minus 6, minus 6 plus 3. So it is becoming minus 1. Y is becoming minus 1. So that's what this graph is cutting here. Here, this point. These are the 2 points. This becomes 0 comma minus 1. Okay. So how do we understand that shift has happened? This shift has happened because this point which was minus 3 by 2, this was shifted. How much it was shifted? Along the x-axis 3 it was shifted. So minus 3 by 2 plus 3 is how much? Tell me first. Minus 3 by 2 plus 3 is how much? Minus 3 by 2 plus 3 is how much? 3 by 2. That means 3 by 2. 3 by 2 it is. 3 by 2. So this point which we are talking about, any point you can take. Okay. Suppose I have taken uh, this point. This point on the graph I have taken. Now where has this point gone? So according to that, we have to add plus 3 in the x coordinate, right? So according to this, we have to add plus 3 in this coordinate. So that become 3 by 2. And then we have to shift also along the y direction. Y direction, if you shift it, where it will go? Y direction, you have to add 2. So y direction, you have to add 2. So this point might have gone to different place. This point might have gone here, 3 by 2. Somewhere here, this point has gone. Okay. This point has come here. And similarly, if I have taken this point, like this point might have also come here. I think here shifting might not be very clear. Let's take another example, then only it will be better. Take another example. Suppose if this is a equation, y square is equal to 2x. Okay, y square equal to 2x graph, y square is equal to 2x graph is like this type of graph. This graph is y square equal to 2x. But I want to plot a graph of y minus 2 whole square is equal to 2x minus 10. I want to plot this graph. So in this graph only we will do changes. What changes we will do? This point is there now, origin. We will shift this origin. So let us shift this origin. You are going to make 10 along x-axis and 2 along y-axis. So this graph will now shift like this. Okay. So this point has become, vertex has become 10 and this has become 2. Exactly same type of graph is there. Okay. So why this graph is important, I will tell. Why this shifting is important to learn. Because this shifting is there in the wave chapter. Waves you have already studied. You know now wave equation y equal to mx plus y equal to a sine omega t plus kx is there, right? Y equal to, huh? Waves is grade 11 topic now. Oscillation and waves you have not studied. Huh? Okay, okay. So let us not go more detail, more mass it will be then. Okay, let's come back to that physics. Okay, so idea that shifting of graph is an important technique to solve question. One advanced question was there, which once came in J advanced, and people were not able to solve that question, you know, because they were even in the faculties from LN and other places, they made a solution which was too lengthy, 2 pages it go, and who will solve that? But we I tried a one shifting of the graph technique, and quickly within few seconds it got solved. That is the power of maths. Maths, if you learn any question tricky, it will make the question tricky. Otherwise, it will go lengthy. Lengthy, we don't have time. 1 minute only, we have to solve question, right? Okay, we'll see that afterwards. So now motion in 2 dimension we can solve. Okay, problems on motion in 2 dimension, and there are many other equations also. I'll give some equations of ellipse also. So this type of equation, x square by a square plus y square by b square is equal to 1. This type of motion, this type of equation represent elliptical path. So if a body is moving like this is called ellipse, and in ellipse, this is called, this is x-axis, this is y-axis, and this distance from this is of course origin 0 comma 0, and this coordinate is a comma 0 or capital A, just write capital A comma 0. This coordinate is minus a comma 0. This coordinate is 0 comma b. This coordinate is 0 comma minus b. Okay, so this axis, x-axis is called major axis, and y-axis is called minor axis. Okay, x-axis is called major axis, and y-axis is called minor axis. And A is this distance from here to here. This is A. This side is also A, right? And this distance is B. This distance is also B. So A is called semi-major axis length. Semi-major axis length. B is known as semi-minor axis length. Okay, semi-major axis, semi-minor axis. Today class, after going through this, you do watch one link in the basic maths. I will send you all the 2 dimensional coordinate geometry. I have discussed that, because for motion in 2 dimension you must have knowledge about 2 dimensional figures. So ellipse, parabola, hyperbola, and all those equations we should have idea, otherwise you will face difficulties.